Welcome back, and in this video we are going to set up the physics asset for our little fern, and in the meantime I just deleted all the physics bodies because I want to start off clean so we can create the rigid bodies all the way from scratch, and we can see what is set. So to begin with, we want to add a root, and I'm going to select the sphere, and I'm going to disable collision because this is not going to be something that we want to collide with. It's just going to be there to anchor the object, because as you saw before, this fern is going to go all over the place otherwise. So if I simulate, well, nothing is going to happen right now. Anyway, you want to set this to kinematic. That means that it's not going to simulate at all. And you also want to move this towards the middle of the fern, so kind of at the bottom of your plant. So if this is not a fern, it just needs to be kind of where you well, really it just needs to be where your pivot of your plant will be. So the stems begin here, and that's where it's going to bend from. So we're going to use that for kind of just for guiding us when we set up the constraints. So let's just make it fairly small. Okay. And that's actually what we need to do in there. So let's create a new body, and this time we will use a fill. You could try an experiment with some of the other ones, but I tried this with a box one time, and it created a lot of jittering, and I guess that's because of the nature of that, of some of the edges. So this fill is going to be good for this, I think. And to begin with, we want to make this quite a bit smaller, so something like this. And one thing when we do this is we want to pay attention to the weight, because when we set the angular motors, they are going to be behaving according to the mass. And also if you at some point wanted to implement something like a braking plant, so you could break off this if you came at it at a very high velocity, then you would have to enable maybe, for example, the braking limits. I can't remember where they hidden away. Angular breakable, for example, or maybe the linear brakes. But what I'm trying to say is that they are being controlled by the mass also. So in order to calculate the braking force needed to apply to this to break off, you would need to take into consideration the mass of the object. So enough about that. What we need to do inside the constraints mode is to select this guy and then move it towards this other rigid body, which is the center, or the location of the stem. So this is where it's going to rotate from. So it doesn't really matter if it's precisely on top of it, but just in this general generally close to the center. Okay. So when we now simulate, okay, right now nothing is happening, but you can see we can move this around now, and so far it doesn't really look like a fern. But we will change that by adjusting a little bit on the constraints. in the constraint mode. So we will enable the angular orientation drive and the velocity drive, and hit simulate again. So if I push this now, you can see that it's gonna fall back again. And for our purpose here, it's still gonna move way too much. As you can see, this is gonna create some weirdness. So we need to play a little bit around with these values. So I'm gonna pick a fairly high number, 1000, and then push it again. And so you can see now it's starting to look like an antenna. And we probably want this to be dampened quite a bit. So as you can see now, it's starting to behave like something that we're after. If somehow you can sometimes end up by having this being kind of broken all the way, you want to have these set to limited, which will trigger this soft swing, and you can also play around with these. So I'm gonna set this to enabled, to limited. If for some reason we want to lock one of these, then you will see that suddenly the angular motors stop working, and the reason for that is because the angular drive mode set to slurp right now, and it doesn't work with any axes locked for the angular motion with this mode. So if you want to limit one of these, you need to select twist and swing, and that will enable the swing, the angular motors again. So yep, that is what we're going to set here. So let's say limited for all of them, and we can get back to this. We probably need to tweak this quite a bit. So let's see. Okay, let's add the next one, and let's see what that does. So this, if we just select this one, we can see we have a mass of about 10, and we want to, for simplicity, you don't need to do this, but for simplicity, I will aim at getting the close to the same weight for all of these. So without compromising the overall structure of this fern. So this looks semi-okay to me. It's not going all the way out, but it's well, it's kind of close, I think. So we're just gonna go with this for now. See if it looks okay, and let's get that one down as well to the center. Just move around it a few times to see if I have positioned it correctly. Alright, so let's set these also to 1000, and I can't remember if it was 250 I said, and twist and swing, limit, like that, and simulate. So now we have 2 branches implemented, so let's see what happens when we swing the other one. That one looks okay. And you can see we have an intercollision between these, and you may or may not want this. If you have your bodies positioned too close to each other, you have to maybe turn off the collision, because with these guys colliding, when you stand on them or in the middle of them, they sometimes create some weirdness, a lot of jittering in the motion. So because these are not really tubes, they may affect each other in a realistic scenario. But since this is a approximation of something, we might want to also change this a little bit. But let's keep it for now. So let's go ahead and make the next one. So add another fill and size that one down as well. Something like that. Okay, that looks okay to me. And put that to the center. That's okay. While we add it, let's just add the last two of them. You may, if you find yourself not being able to match up your mesh with these rigid bodies, you can actually add, for example, you could actually add one here and another one also here. So they would both, as you can see, be connected to this same joint. But this is just going to be a simplified version. So I'm just going to do this, and it's actually, so far it seems to work out pretty okay, as far as I can tell. Just going to size this up a little bit like that. Okay, and let's get that one in position. And oops, it's too far. Okay, it's completely off actually. Looks okay to me. And the last one. Okay, and get this one down. Okay, so with that in place, let's Control A to select everything, and then let's just set all of these to limited and keep the default values here. So select everything, choose angular orientation drive and set them all to 2500 and all these to 750 and twist and swing, and let's simulate. So right now things look pretty okay. I think this is a good setup to begin with, and I think we are going to go with this for now, and we will probably adjust this a little bit on the way, but it's a good start. Actually, before I end this video, let me just mention one thing. If I end this like this, we have all of them selected. We want to disable gravity for these because we don't actually want gravity to affect them. Want them to just find their own way back according to the swing limits, and yeah, that is actually it so far. What we can do just to test this, we have everything selected now. So if we click collision off, that means that all of the selected bodies will not collide with each other. So if I now hit something, we're only going to affect one rigid body, and they are going to just pass through each other. So this, if things start to get jittery and intercollide constantly and cause all kinds of problems, that is something we might do. I think I'm gonna set collision on again, and set simulate, and we have things colliding now. But that's just a setting that you want to know that you can change. Yeah. So in the next video we will see how we can also actually get to interact with this guy here. So stay tuned, and thank you for watching. Bye bye.